Assalamu alaikum wa rahmatullahi wa barakatuhu, and good morning to everyone present for this session. Welcome to Sarosh Digital Learning, Class 7th, Science Subject, Chapter number 17, Effects of Light. In the last session, we have studied of page 113. In that, one experiment was given which we have understood by taking the requirements or the apparatus which were used in this experiment. And that experiment was a beam of laser light. For that we have taken beaker, laser pointer and clear water. So we will be doing the next following experiment 17.2, which is given on 114 page, scattering of light. Now instead of using milk, we will be using mixed salt, sugar and detergent powder in separate beakers of water and observe whether a laser beam is seen in them. Apparatus to be taken for this experiment is a table lamp with a 60 or 100 watt milky bulb. In other words, it can be called as LED will not do. Thick black paper, sticking tape, a packing needle, 100 or 200 ml glass beaker, milk or milk powder, dropper, spoon, etc. If we take these apparatus, you have to set. First thing is that you will cover the mouth of the lamp shade properly with black paper using sticking tape like it is shown in the figure 17.2. Prick a hole of 1 to 2 millimeter diameter in the center of the paper. With the help of the packing needle, take clear water in the beaker. Light the bulb and place the beaker in contact with the hole. Observe from the front and at an angle of 90 degree. Now add 2 to 3 drops of milk to the water and stir it very well. And then observe again. A few more drops of milk may have to be added to make the water turbid. A blue tinge is seen when observed along the 90-degree angle. This is the scattered blue light. Because the blue light is scattered, a red-yellow light is seen from the front and the hole appears reddish. The hole which was done on the black paper, there the hole appears reddish. Okay, students? So, and the very important thing that this experiment, it should be done in a dark room and by small groups of students. That means if students stay nearby, 3 to 4 students can do at a time in a dark room. So, have you all understood this experiment, students? Now, let us move towards page number 115. 115. Here we will see that how the shadow obtained from a point source and extended source. Figure 17.3 is showing us that how the shadow formed by a point source. For that, you will require the apparatus such as candle or a torch. Either you take candle or you take torch. Cardboard, screen, small ball, big ball, etc. Now, the procedure for this is take either a candle or torch as a light source. Now, which is the light source here, students? Either a torch or a candle. And in front of it, set up a cupboard with a tiny hole. With a tiny hole. As shown in the figure, now the light is seen to emerge from the hole on the cardboard. Emerge means which comes out. Such a light source is called point source. Point source is torch or a candle which is kept, and by taking the help of this light source, what is seen? What is seen on the cardboard? The light is seen to emerge from the hole on the cardboard, and such a light source is called point source. Place a screen vertically at a distance of 1 meter beyond the cardboard. Hang the big ball between the screen and the cardboard. This is the ball here which is hanged between the screen and the cardboard. Observe the shadow AB of the ball. Now what is the AB here? This is AB. You have to observe this. And when this light source will pass through this hole, and in between the ball is hanged, so that the shadow of this ball, it falls on this sheet. The rays OP and OQ starting from the point source just pass by the ball and fall on the points A and B on the screen respectively. However, since no rays reach the screen between the points A and B, there is no rays which reach the screen between A and B. That part remains unlit. This is the dark shadow or the umbra. Dark shadow, it is called as umbra. What happens if the cardboard with the pinhole is removed? Now we do not have a point source. Then this source is called an extended source. When we are not using the pinhole which is removed and the point source, then that source is called an extended source. What is the nature of the shadow formed by an extended source? Due to the extended source, we see two parts in the shadow of the ball on the screen, one faint and one dark. One faint means light shadow and one dark means very bright. The faint part BC is called the penumbra. That means faint part is penumbra and the bright part is called the umbra. Let us see what happens in the following activity, which the ball is bigger than the extended source. Keeping the distance between the extended source and the ball constant, move the screen further and further away and observe the shadow. Now both the shadows you have to observe. One is dark and the other one is faint. As the screen moves further, the umbra and the penumbra is the shadow of the ball are seen to become bigger and bigger. Now replace the big ball with one that is smaller. You are going to replace the big ball with one that is smaller in size than the light source. Observe its shadow on the screen. We see the umbra and penumbra of the ball on it. Now, without moving the light source and the ball, move the screen further away from the ball and observe its shadow. As the screen moves further, the umbra becomes smaller and the smaller, and at a certain point it disappears. That means if it is kept little further away, then what happens? The umbra becomes smaller and smaller, and at a certain point it disappears. Okay students, so today we have learnt page number 114 and page number 115. Inshallah, in the next session we will be continuing this chapter. Till that time, you are going to go through these pages which I taught today. Thank you children.